right, everyone. So let's get started with our guided review of prerequisites. So up first we have vocabulary. So we're just going to go over a few terms, just to kind of kick us off, just things that you may already know, but just in case, just so that they're clear, we'll have the vocabulary for this class. So a coefficient, oh, new pen. A coefficient is the number before variable. So in our example here, 12x, 12 is our coefficient. Terms are the parts of an algebraic expression that are separated by addition or subtraction, and like terms must have the same variables to the same powers. So I've heard this before called the same last name. Whatever we've got going on, so the number here, our coefficient here, doesn't really matter, but the variables and their exponents do. So if we're looking at this 5x cubed plus 3x squared times y minus 2y plus x squared times y, we're looking and we see we have, for this term, we have 5x cubed, and we don't have any other terms with x cubed. So this is a term, but there are no like terms with it. 3x squared times y. This is another term, and we do have another x squared times y. So these are going to be like terms. They have the same variables, x and y, with the same exponents, 2 and 1. Remember, if we don't write an exponent on a variable, that means it has an exponent of 1. So these would be like terms. And then minus 2y, no like terms with that. So this original expression here has a total of 4 terms. And we could simplify this by combining our like terms. If we want to combine our like terms, we keep everything else the same. That 5x cubed is going to stay the same. But then this 3x squared times y, we add those coefficients. So 3 plus 1. If there's no coefficient written, it's a 1. So plus 4x squared y. And then that minus 2y is also going to stay the same. All right, up next, a factor is a number or expression that divides the given number or expression evenly or exactly. So for example, if we wanted to know the factors of 12, well, 12 divides 12 evenly or exactly. And we always start with the number itself, and you can kind of work your way down. So 12 divides the number evenly or exactly. 11 does not. 12 divided by 11 is not good, not a whole number. 12 divided by 10, no. 12 divided by 9, no. 12 divided by 8, no. 12 divided by 7, no. 12 divided by 6 gives us 2. 12 divided by 5, no. 12 divided by 4 gives us 3. 12 divided by 3 gives us 4. 12 divided by 2 gives us 6, and 12 divided by 1 gives us 12. So those are going to be our factors of 12. You could actually start this from the other direction too. Okay. A constant is a number without a variable that is being added or subtracted from an algebraic expression. So for example here, we have 4t plus 3. In this case, t is our variable. So this plus 3, that is a number without a variable that's being added to this expression. So this plus 3, that is our constant. It is the constant term. By the way, this has 2 terms, right? The 4t and the plus 3. These are 2 different parts of this algebraic expression that are being added together. All right. The degree, and we're going to learn more about degree later. We just need to know just a little bit about it now, and we'll get into this more as the class progresses. But the degree of an expression is the greatest exponent on a variable. So if we're looking at this, we see x cubed minus 4x squared plus 2. The exponents that we have on variables here, we've got this 3, we've got this 2. This 3 is greater than the 2, so this is degree 3. This is a third degree polynomial. This is a third degree expression because we have a greatest degree of 3 on a variable. And then lastly of our vocabulary, the leading coefficient. The leading coefficient is the number before the variable with the greatest exponent. So we talked about coefficient first. Coefficient is the number that comes before the variable. The leading coefficient, we need to find that variable with the greatest exponent. In this case, we have 2x squared plus 3x plus 4. So our greatest exponent is that 2. And so our leading coefficient, we find that out front. That is also this 2. So our leading coefficient is 2. Okay, so that's what we've got for vocabulary. Of course, there will be more vocabulary, but this will get us started. And let's go ahead and do this as well before we get into the factoring. So order of operations and arithmetic. So hopefully everyone is already familiar with the order of operations, but sometimes it's good to have a refresher. So up first, we've got, PEMDAS. This is our acronym that we use for the order of operations. So we're going to do parentheses and other grouping symbols. So for example, if we have absolute value bars or brackets, those go with the P. Those go with parentheses. And then we have exponents. And then we have multiplication and division. When we're doing multiplication and division, we do those at the same time and we work from left to right. And then addition and subtraction. And again, we do those at the same time and in the same step, and we work from left to right. So let's see a few examples. So if we have 3 times 5 minus 7 to the 4th, first we look for parentheses, and we've got some. We have 5 minus 7 in parentheses. So we're going to start, we'll rewrite that 3, but then we simplify what we've got inside those parentheses. 5 minus 7 is negative 2, and then we have to the 4th. All right, so our parentheses are handled. We've done everything we can inside of those parentheses. E, exponents. We have an exponent here as well, so we're going to handle this 4th power next. This 3 is just going to hang out. And then negative 2 to the 4th power. Remember, a 4th power tells us to multiply something by itself that many times. So negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 gives us positive 4. Times negative 2 again gives us negative 8. And times negative 2 a 4th time gives us positive 16. And then 3 times 16 gives us 48. And so this whole thing here simplifies to 48. All right. 5 plus 9 minus 5 times 3 squared. All right, so we start by looking for those parentheses. We've got 5 plus 9 in parentheses here. So we're going to start with that. 5 plus 9 is 14. And we don't really need those parentheses anymore. We needed them here because there was still an exponent, and then we needed them at this step because we were multiplying something on the outside. Here, since we're just subtracting something from it, we can drop those parentheses. They aren't doing anything for us anymore. All right, and then we can rewrite the rest of it. Minus 5 times 3 squared. All right, so that handles our parentheses. Up next, exponents. So we've got this square here. 14 minus 5 times 3 squared, so times 9. 3 times 3 gives us 9. All right, up next, multiplication and division. So we've got a multiplication, so let's handle that. 14 minus 5 times 9. 5 times 9 is 45. And then lastly, we do that addition or subtraction. So we've got the subtraction. 14 minus 45 should give us negative 31. All right, one more. So if we have 5 plus 13 over 2 squared times 7 minus 1 in parentheses. So when we're looking at this, a fraction bar written like this, we treat this like a grouping symbol. We think of the top as grouped together and the bottom as grouped together. So we can't simplify anything between the two of them until we've first handled what's going on top, what's going on bottom. That's going to be our very last step. So let's do the 5 plus 13 first. So the 5 plus 13 is going to give us 18. And now we can also simplify our bottom. Our bottom's going to take a bit more work. 2 squared times 7 minus 1. So when we're looking at this, think back to PEMDAS. Our first step is parentheses, so we're going to do that first. We'll have 2 squared, 7 minus 1 gives us 6. Okay. So then next up, we've handled our parentheses. Next up is E for exponent. So we'll do this 2 squared. 18 over 2 squared is 4 times 6. I'm going to move down here. All right, and that 18, we can't do anything with it until we've completely simplified that bottom. 4 times 6 gives us 24. And so then 18 over 24, we can simplify that. And if you aren't familiar with how to simplify fractions, you can think of it as dividing the top and bottom by the same number. So if we're looking at 18 and 24 and we're asking what common factors do they have in it, that's why we did that factor stuff. Well, the greatest common factor that they share is 6. So if we divided the top by 6 and divided the bottom by 6, we have to do both or neither. We can't just divide one of them. Divide the top by 6 and the bottom by 6. We'll end up with 3 over 4. All right. And that is our vocabulary and order of operations overview. Up next, we'll be getting into factoring.